So really this lesson is on dividing polynomials. We're going to talk about remainder theorem tomorrow, so I don't know why that's part of the title. First thing, a few definitions which will seem kind of convoluted until we get into this a little bit. So these are just kind of standards that I use. I don't think the textbook really uses this notation. It's a little bit of a standard notation, but it's not necessarily universal, but it's here so that you know, if I use that notation, what it means. The more important thing is that you know these words, the dividend, the divisor, the quotient, and the remainder. You have to know what those things mean. So f at x is the dividend. This is the function that we're starting with. This is like our original function. And then d at x would be the divisor, so what we're going to divide by. The quotient is the result, so that's what you get when you divide, right? And then the remainder, r at x is the remainder, and that's what's left if you're asking about dividing evenly. You know this stuff, maybe not those words exactly, but from elementary school when you did long division. Did you do long division in elementary school? Did you dislike it passionately? Did you? Well, guess what? We're going to do long division again today. So people, it's so funny. You know, society's so interesting. Like, oh, who's ever going to use long division? Well, if you take advanced functions and you start talking about factoring bigger polynomials, you have to know how to do long division. So it's actually good that you learned how to do it. It'll be a lot easier this time around, trust me. Anyway, so that's what we're going to do. So if we set this up in long division, because we do understand that notation, it would be d at x divided into f at x. My result is q at x. And then if I have a remainder, which you don't always, that would go there. How many times does 2 go into 11? 5. And then ... you'd end up with remainder 1. It's so interesting how things come back around. This is a side note, but it just reminds me of if anybody ever takes math in university, even if it's not like your major, but if you take any math courses, you may experience what's called modular math. And if you did any computer programming, 100% you would learn about modular math. So anybody who's going into any kind of computer programming, engineering, or like computer science, you will learn about modular math. It would be a really important tool that you would use in computers. And it's kind of like dividing and having a remainder in different ways. Like, it's more complicated than that, but again, like, it comes around to when you learn long division in grade 4 or whatever it was, it comes back around where all of a sudden you're in university and you start doing modular math and it's kind of the same, talking about remainders, that kind of thing. It's interesting how things come around. Anyway, okay, so that's just a quick little reminder of some ideas of notation. Oh, and I don't have room to write this, so maybe I'll write it after our division statement. I was going to put that there, but no room. Okay, so 2 methods that we're going to learn how to do it. You will have a favorite. I have a prediction of what your favorite is, but you need to know both. Okay, you need to know both. First one we're going to look at is called long division, like I said. So let's get started. Divide each polynomial by the given divisor using long division. So here we go. X plus 3. So f at x is my function. It's what I'm dividing into. What am I dividing it by? D at x, which is x plus 3. So this question could have been written x cubed plus 4x squared plus 6x plus 5 divided by x plus 3. Like, I think the textbook uses the division symbol kind of thing. So we start with the x. How many times does x go into x cubed? x squared. Put it over the x squared term. Then I take that x squared and multiply it back by everything in what I'm dividing by, x plus 3. So x squared times x is x cubed. X squared times 3 is positive 3x squared. X cubed, then we subtract. Is this familiar? Bringing back old memories? No? From long division? Bringing back old memories? So x cubed minus x cubed is 0. That has to work out that way, right? That's the point. 4x squared minus 3x squared is 1x squared. I bring down the 6x. X goes into x squared x times, just dividing, right? X squared, this x squared down here divided by x is x. And then multiply, so x times x is x squared. X times 3 is 3x. Subtract. X squared minus x squared is 0. 6x minus 3x is 3x. Bring down the 5. How many times does x go into 3x times? Or in other words, 3x divided by x, so that's 3, so plus 3. 3 times x is 3x. 3 times 3 is 9. X minus 3x is 0. 5 minus 9, negative 4. Done. We make our division statement. We don't have to write division statement every time, but that's what it's called. And the division statement is f at x equals d at x times q at x plus r at x, using that notation from before. So f at x equals x plus 3, x squared times x squared plus x plus 3, minus 4. I have a remainder of negative 4. Think about what that means if I compare it to the long division that I pretended to do above with numbers. I had a remainder of 1. When I divide 2 into 11, I have a remainder of 1. What does that tell us? It tells us 2 does not go into 11 evenly. 2 is not a factor of 11. Right? Does that make sense to you? You understand what I'm saying? What if I did 2 divided by 10? How many times did 2 go into 10? 5 times. ... Remainder 0. 2 is a factor of 10. It goes into 10 evenly. Does that make sense? So I did not have a remainder of 0. I had a remainder of negative 4. So it's not a factor. That's going to be important down the road. Something just to think about while you're doing this. Like, make sense of it to yourself. What does it mean to have a remainder? It means the same thing when you're dealing with numbers. It means it doesn't divide in evenly. So it's not a factor. Let's try another one. Be a little bit careful of this one. So we're going to set it up. X minus 2. 2x to the 4th. So this is a degree 4 polynomial. Plus 5x squared, cubed, minus 7x. There's no x squared term. But we need an x squared term. Like you don't just skip it just because it's not there. The division process requires it. And that's true of numbers as well. Like 107 has a 0 in the tens column. That's an important placeholder. We don't need it in algebra notation, but the idea is still there. There exists an x squared term. It just has a coefficient of 0. Same thing as a 0 placeholder in the tens column or something like that, right? So plus 0x squared. That's easy to miss when you're going through this quickly. You'll forget. But then you'll get halfway through the process and you'll be like, something is not working here. This doesn't feel like the last ones that I did. And then hopefully you'll notice, oh yeah, right, I forgot one of the terms. So pay attention to that. That's an easy thing to miss, but it's very important. The whole process will fall apart without it. And so if you just know that that's an easy mistake to make, and that's you get a weird feeling when it happens, you might be able to catch it. Okay, so x goes into 2x to the 4, 2x cubed times. And try not to go into like autopilot mode where then you just write 2x to the 4 down here. Do the multiplication in your head. Make sure it works. Some questions will be more complicated. I could have a coefficient out here. I could divide by a trinomial. Like it does get a little bit, some of the examples are a bit more complicated. So 2x cubed times x is 2x to the 4th. Okay, good. That means I did it right. That's my check that I got the right number up there. Then I go 2x cubed times negative 2. So negative 4x cubed. Subtract. First column 0. 5x cubed minus negative 4x cubed is 9x cubed. And here's where this is important. X goes into 9x cubed plus 9x squared times. Woo. So that's plus 0x squared. Bring that down. So 9x squared times x is 9x cubed. And 9x squared times negative 2 is negative 18x squared. Subtract. 0 and 0x squared minus negative 18x squared is positive 18x squared. Bring the negative 7x down. X goes into, why don't you try this one? So you should get x goes into 18x squared, 18x times. And you get 18x squared minus 36x, 18x times negative 2. Negative 7 minus negative 36 and negative 7 plus 36, 29. So x goes into 29x 29 times. x and 29 times negative 2 is negative 58. 10 minus negative 58 looks like 68. Again, I have a remainder. That's not 0. So that wasn't a factor. It didn't divide through evenly. I know it's not like, it's probably not as intuitive, but what does it mean to divide in, like one polynomial to divide into another polynomial evenly? Like, what does that even mean? But you'll find out a lot about that tomorrow, it'll be obvious. Okay, so make our division statement. F at x equals x minus 2 times 2x cubed plus 9x squared plus 18x plus 29 plus 68. And if you expanded that, you should get back the original function. You should get back the original f at x, right? They're the same. That is still, that's a different version of f at x from the one that we started with up there. So you could check that by expanding. Should work out. Any questions? That's long division. We have another process called synthetic division. Synthetic division is going to look like this. D at x. F at x. Down here will sort of be Q at x. And over here will be R at x. Morning, thank you. Okay, so let's give it a try. So we put x plus 2 over here. And we just put the coefficients here. So the coefficient of x cubed is 1. They've got to be in order. Absolutely. Like if you were given a function written out of order, you'd have to reorder it. Negative 5. Same with above. I think that's obvious. Negative 1 and 12. In my head, the process of long division makes sense. Like, I know it's been a while since you've done it, but I think when you're doing it, you feel like you are actually dividing the polynomial, whereas synthetic division is like, it's almost like a trick. Like, it doesn't make a lot of sense. It's an algorithm that gets us the answer. So you have to memorize the algorithm. Like, you wouldn't be able to figure it out on your own. So I bring down the 1. Then I multiply it by the 2. So 2 times 1 is 2. I put it over there. Then I subtract. Negative 5 minus 2 is negative 7. And I multiply by the 2 again. 2 times negative 7 is negative 14. Then I subtract. Negative 1 minus negative 14. Negative 1 plus 14 is 13. Multiply by 2, 26. (12 minus 26), negative 14. That's my remainder. And I'm done. That was a lot faster. How do we do our division statement? So f at x equals x plus 2. See, I know, like, you're like, what do you mean we're done? There's not even a polynomial, like there's nothing there. But how is that massive numbers an answer? Okay, so my exponent is decreasing, right? I had an x cubed, I divided by x, so my result has to be an x squared. So this is 1x squared minus 7x plus 13 plus my remainder of negative 14. Any questions about that? Let me go over it quickly again, just watch. And this is, like, I'm recording this, right? So you can watch this online later if you want. You need to go back over how to do synthetic division. I bring down that first one, just bring it down. Then I multiply 2 times 1 to give me the 2. Then I subtract 2, negative 5 minus 2 gives me the negative 7. Then I multiply 2 times negative 7 to give me the negative 14. Then I subtract negative 1 minus negative 14 plus 14, so that's 13. Then I multiply again. 2 times 13 is 26. Subtract 12 minus 26 is negative 14, which gives me my remainder. Okay, let's try it again. So line up my coefficients. 2, 5, look, the x squared term is missing again, so we need a 0, negative 7, and 10. First step, bring down the 2. Negative 2 times 2 is negative 4. 5 minus negative 4 is positive 9. Negative 2 times 9 is negative 18. Zero minus negative 18 is positive 18. Negative 2 times 18 is negative 36. Negative 7 minus negative 36 plus 36 is 29. Negative 2 times positive 29, negative 58. And 10 minus negative 58, 10 plus 58, 68. That's my remainder. So there's my quotient, my result, 2x cubed plus 9x squared plus 18x plus 29 plus 68. Does that look familiar? It was the same question we did up there, 2 different ways. Right? Same question, same result. Checks out. And if you compare them, you can see what synthetic division is doing. Like you can kind of make sense of the process. You need to know both. Like you'll be asked on a test, solve the, and in fact, the quiz on Friday will give you one, solve using long division, one question. Question number 2, solve using, or divide, sorry, using synthetic division, right? So you're gonna just show one of each. Yes? So this was, it started with a degree 4. So my result is going to be typically 1 less. Not always. It's going to, like if I was dividing by x squared, then it's going to be less. But you could work backwards. So this is going to be my constant. So there's my x term, x squared, x cubed. Like it'll always end with that constant. So you could work backwards. If there's 4 terms, or if there's 4 coefficients like that, then it's got to be a degree 3, because a degree 3 polynomial is the one with 4 terms in it, right? If one of the terms was 0, if it was like 0x squared, then you'd see a 0 in there. Like it would be there. So you'd still know I've got 5 things here. So that's got to be a degree 4. 4, 3, 2, 1 constant. But then one of them might be a 0, so you wouldn't write it in your result, but it'd be there. Any other questions? All right, there's a few for you to try.